Hello friends, in last two videos we have seen elementary particles. In this video we will see composite particles. Now composite particles are called hadrons. There are two kinds of hadrons. One is the mesons and one are the baryons. Now mesons are the composite particle of two quarks and baryons are the composite particles of three quarks. Now when we say that a meson is composed of two quarks, then it means one is the quark and other is the antiquark always. Now, these two quarks can be different from each other or they can be same. Now, one more important thing is that these two particles or two quarks must be following the Pauli's exclusion principle because they are fermions. A quark is always a fermion and therefore each of these quarks must be possessing a different quantum mechanical state from each other. So even if they are same, so they can be identical, but they have to be possessing different quantum mechanical states so that they can follow the Pauli's exclusion principle. Similarly, baryons are the composite particles of three quarks. Now these three quarks can be same quarks or they can be different quarks or two of them can be same and one is different. So any situation can happen, but baryons are always composed of three quarks, and again, since the quarks are fermion, so all these three quarks must be following the Pauli's exclusion principle, and therefore each of these three quarks must be possessing a different quantum mechanical state from each other. Now, one more thing is that mesons are always bosons and baryons are fermions. So when I say meson is a boson, then you should not think that Q bar are fermions. Yes, they are fermions, but the whole particle is a boson. Now here I provided the list of mesons and baryons that were experimentally discovered. Now here we have a list of spin zero mesons. Spin zero mesons are also called pseudo-scalar mesons along with their masses, lifetime and principal decays. Masses are in mega electron volt by c square, lifetime is in second, and we have the principal decays. So I will try to enumerate the particles in the list. So first of all, we have pi plus pi minus and their core components are u d bar and du bar. And these two particles, actually these are two particles, one is the pi plus and one is the pi minus. Then we come to pi 0 and its core component is u bar minus dt bar divided by root 2. Actually this is a mixture of quarks. This is actually the right quark composition for pi 0, but for now you just remember that u bar is the quark composition for pi 0. Later we will see how this mixture quark composition u bar minus dt bar by root 2 has come because of the isospin combination of the quarks. So these three, pi plus, pi minus, pi 0, these three are called pions. Now come to k. These are called kaons. So k plus, k minus, these are the two particles. K plus for which the composition is u s bar and k minus for which the composition is s u bar. Then next we have K0 for which the composition is D S bar, and then K0 bar for which the composition is S D bar. So we have total of 4 K mesons. These are called kaons. So we have 4 kaons. Then we have eta, and for which the composition is U bar plus D D bar minus 2 S bar divided by root 6. Again it is a mixture quark composition. Obviously this is the real quark composition for eta, but for convenience sake, for now you should remember that for eta the quark composition is dd bar and not this one. Now let us come to eta prime. For this the quark composition is u bar plus dd bar plus ss bar by root 3. Again it is the mixer composition, but now we will not make it tough and we will say that eta prime has the quark composition of ss bar. Now one more thing is to be understood that the pions, that pi plus and pi minus, they are the antiparticles of each other. So pi plus is the antiparticle of pi minus or vice versa, but pi 0 is the antiparticle of itself. Similarly k plus k minus, they are antiparticles of each other. K plus is the antiparticle of k minus and vice versa, and k0 and k0 bar, they are antiparticles of each other. So k0 bar is the antiparticle of k0 and vice versa, and eta is the antiparticle of itself. Eta prime is also antiparticle of itself. Okay, let's come back to d mesons. So we have d plus, d minus. These are two particles. D plus has the composition c d bar and d minus has the composition d c bar. These d plus and d minus are antiparticles of each other. Similarly, we have d0 and d0 bar. They are also antiparticles of each other and they have their core compositions given. Similarly, we have ds plus and ds minus. And you can see one thing, that all these d particles or the d mesons have one c quark, that means one charm quark. So the d mesons basically contain one charm quark. Then we have B mesons, and B mesons, so first of all, B plus B minus, these are the two particles and they are also antiparticle of each other. They contain U B bar and B U bar. Similarly, we next have B0 and B0 antiparticle or B0 bar, that is D B bar and B D bar. And it is to be noticed that all these B mesons contain one bottom quark. Then there are also mesons that have spin 1, so these are called the spin 1 mesons or called vector mesons. Now the first spin 1 meson is the rho meson, and it has three particles. Actually three rho mesons are there, rho plus, rho 0 and rho minus. So you should understand here that there are three compositions. For rho plus u d bar, for rho 0 u bar minus d d bar by root 2, and for rho minus d u bar. Then we have k star mesons. So there are actually four k star mesons, k star plus, k star minus. They are antiparticle of each other and their compositions are u s bar and the last one s u bar. And we again have k star 0 and k star 0 bar, and they are also antiparticles of each other. Their compositions are ds bar and sd bar. Those middle two compositions are those compositions. Yes, in the charge column there should be two zeros in between 1 and -1, but actually that 1 0 represents both the zeros. Okay, then we next move to the omega meson. Omega meson is the small omega, and in the case of baryons we will say there will be a capital omega which will be a baryon. So here it is a meson and it is the antiparticle of itself, and its composition is u bar plus dd bar divided by root 2. Then we have psi meson, and it is the c bar, that means charm quark and anti-charm quark. So this charm quark, anti-charm quark make psi meson, and it is the antiparticle of itself. Next we have 4 d star mesons, and out of 4, 2 are d star plus and d star minus, and they are antiparticles of each other, and their compositions are given by c d bar and the last one d c bar. And the 2 are d star 0 and d star 0 bar, and they are also antiparticles of each other, and their compositions are c u bar and u c bar. The middle two compositions are the compositions of these two particles. And next we have upsilon. Upsilon is b bar, that means the composition of bottom quark and the anti-bottom quark, and this is the antiparticle of itself. Now we will see the list of baryons, and first of all we will see the spin half baryons along with their charge, mass, lifetime and principal decays. Mass is in mega electron volt by c squared, lifetime is in second, and we also have the principal decays. So we will start with the first and the simplest and the lightest baryon, that is the proton, and it is having the quark composition or the quark content UUD with charge 1 and mass 938.272 mega electron volt by c square, and it has lifetime infinite, and that is why it doesn't decay normally, because it has infinite lifetime. So how can it decay? And next is the neutron. So neutron has quark content UDD and charge 0 and mass is 939.565 mega electron volt by c square, and lifetime is 885.7 second, that is about 15 minutes, and it decays into proton plus electron and neutrino. Now next we have the lambda baryon, which is having the quark content UDS, charge 0, mass is 1115.68 mega electron volt by c square, lifetime is 2.63 into 10 to the minus 10 second, and principally it can decay either to proton plus pion minus, or it can decay to neutron plus pi 0. Then we have sigma, and there are 3 sigma particles or 3 sigma baryons, that is sigma plus, sigma 0, sigma minus, and their compositions are UUS, UDS and DDS. Now one thing is very important here, that this sigma plus is not the antiparticle of sigma minus, because here the antiparticle of sigma plus would be U bar, S bar, and the antiparticle of the sigma minus would be D bar, S bar, and therefore these are all the particles. So unlike the case of mesons where we had particles along with their antiparticles, but here only we have the baryons, the particles, not their antiparticles. So all these are particles. Then the next baryons we have are xi 0, xi minus, They are also called cascade 0, cascade minus, and their quark compositions are USS and DSS, and they have their corresponding charge, mass, lifetime, and principal decays. Then the next baryon is lambda C plus, which is having the quark composition of UDC. Now, having seen spin half baryons, we will move forward and see more baryons of spin 3 by 2. So the first spin 3 by 2 baryon is delta. Actually, there are 4 delta particles or 4 delta baryons: delta plus plus, delta 0, delta minus. So delta plus plus is UUU, and delta plus has the composition of UUD. Delta 0 has the composition of UDD, and delta minus has the composition of DDD. So these are the 4 particles, and for all these 4 particles the mass is same, that is 1232 mega electron volt by c square, and the lifetime is again for all the particles is same, that is 5.6 in 10 to the minus 24 second. So there are 4 particles, and all those 4 particles having different charges but same mass, same lifetime. Now the next 3 by 2 baryons are sigma star, and there are 3 sigma star baryons: sigma star plus, sigma star 0, and sigma star minus. For sigma star plus, the composition is UUS, for sigma star 0 UDS, and for sigma star minus DDS. And the next spin 3 by 2 baryon is Xi star, and there are 2 Xi star baryons available: Xi star 0, Xi star minus. Xi star 0 is having the composition of USS, and Xi star minus is having the composition of DSS. And the next one is omega minus, and this is a baryon. In case of mesons, we had a omega that was small omega, and it is a capital omega. So omega minus is a baryon, and it is having the composition SSS. All the particles are strange quarks. Now friends, I want to draw your attention to one very important question here, that in the segment of spin half baryons there is a particle sigma plus, and it has the quark composition UUS. In the segment of spin 3 by 2 baryons there is sigma star plus, and that has the quark composition of UUS. So the quark compositions are same, but sigma plus and sigma star plus are the different particles. So how could it be possible that the particles are different but their quark compositions are same? Similarly, sigma 0, sigma minus, they have the quark compositions same as the quark compositions of sigma star 0 and sigma star minus. And you can also see that the Xi particles, Xi 0 and Xi minus, are also having the same quark compositions as the Xi star 0 and Xi star minus. Now we can see the similar thing for mesons also. The pi mesons and their quark compositions are exactly same as the rho mesons and their quark composition. So you can see for pi plus it is U d bar, and for pi minus it is d u bar, and for pi 0 it is u bar minus d bar by root 2. Exactly same things we can find for rho meson. For rho plus meson it is u d bar, for rho 0 meson it is u bar minus d bar by root 2, and for rho minus meson it is du bar. So again, how is it possible that the particles are different but their quark compositions are same? So similarly, we can also see that K plus minus and K0 bar, there are 4 kaons, and they have the same compositions as K star particles. So what is the reason behind it? So friends, the answer is that we know about the hydrogen atom with an electron moving around it. Now if the electron is in ground state, then the hydrogen atom is in ground state. If the electron gets excited to some higher energy level, then it is called that the hydrogen atom is in higher energy level. And if the electron gets excited to more higher energy level, then we still say it is hydrogen atom. So one thing is to be noticed, that all the different energy states are being called the same hydrogen atom. So all the different states, but we call only hydrogen atom. Reason for this is the energy difference between these states is very small. It is of the order of few electron volts, and that's why all the different states are called the same hydrogen atom. Now let us come to the combination of quarks, that means baryons and mesons. So the combination of same quarks can have different energy states, just like the hydrogen atom. But in this case, the energy difference between the different states is very large. and that's why different energy states combinations are considered as different particles. That means the same baryon with different energy states are different particles because the energy difference between these states is very large. And similarly, the same meson with different energy states are different particles because the energy difference between these states is very large. Thank you, friends. Please support me by going to the description box. Thank you again.